अरे मेरे प्यारे बच्चों, I welcome all the students from all over the India, from Kanyakumari to Kashmir. I am your Mohan sir, physics master from Hyderabad. Yeah, good morning, good afternoon, good evening and good night. Today we are going to discuss about the electric current, that is Kirchhoff laws. We are discussing about the Kirchhoff laws. Kirchhoff laws. So we are discussing about the Kirchhoff laws. The Kirchhoff scientist, he has given two laws for us. The first one is junction law. Kirchhoff is also called as current law. Kirchhoff current law is also called as junction law. First law is called as junction law. Second one, loop law. Second one is called as loop law, or is also called as Kirchhoff voltage law. Kirchhoff voltage law. So junction law and Kirchhoff voltage law. These two things we have to observe it very carefully. The first one, junction law. Junction law means the algebraic sum of the currents coming into the junction is equal to the algebraic sum of the currents which are flowing away from the junction. The sum of the currents entering into the junction is equal to the sum of the currents leaving the junction. एक एग्जाम्पल ले लो, हमारा काजीपेट railway station junction, काजीपेट वरंगल, तेलंगाना state. Yeah, in that railway station junction point, काजीपेट junction point, some trains are approaching. 1 minute, 2 minutes they will stay and they will leave. So the number of trains which are coming to the junction, railway station, has to leave the junction. Yeah, how many platforms are there? 2 or 3 platforms are there. So the trains entering the junction should leave the junction. So the sum of the currents meeting at the junction should leave the junction. You take one tree, you just observe the tree. Under that it has so many roots are there, so many roots, and there is one trunk, and above the trunk we have so many branches. Below the trunk so many roots, above the trunk so many branches. So the number of roots connected to the lower part of the branch is equal to the number of branches connected to the upper part of the branch. The same way, if you consider the number of currents meeting at the junction, so if you take the first one, the current law, Kirchhoff current law or junction law. Junction law. The sum of the currents meeting at the junction. The sum of the currents. The sum of the currents meeting at the junction. Meeting at the junction. At the junction. How many currents are meeting at the junction? The same number of currents are leaving at the junction. Is equal to the sum of the currents leaving the junction. Sum of the currents leaving the junction. So we can take the algebraic sum of the currents. The algebraic sum of the currents is equal to 0. The algebraic sum of the currents is equal to 0. How many currents are entering into the junction? That many currents has to leave the junction. Just like the trains coming and going at the junction. So here I will give one example for you. The algebraic sum of the currents. The currents which are coming into the junction is equal to the currents which are leaving the junction. If you take one example, I will give one example for you. Just if you observe here, if you observe one junction is there and the currents are coming here. I am taking my junction here. Let I1 is the current coming inside I2 is the current coming inside, and IT is the current going out of the junction. And you are taking I4 is the current coming into the junction, and you take I5 here, I5 and I6. So at this junction point, the algebraic sum of the currents must be 0. That means the current you are taking the arrow direction towards the junction is I1, I2 and I4 and I5. So the currents here I1, I2, next coming current inside is I4, and the current which is coming inside is I5 should be equal to the currents which are leaving outside of the junction. So I3 is going out and I6 is going out. So it is I3 plus I6. So the current, sixth current is going out of the junction. Sixth current and third current is going out of the junction. So the currents coming into the junction should be equal to the currents leaving the junction. So here we are observing in this junction point I1, I2 and I4 and I5 are coming inside. The currents which are leaving here, the current which is leaving I3 and I6 are leaving. So when you take the entire equation, that is I1 plus I2 plus I4 plus I5. Now that currents which are other side, when you equate it to this side, left side, when you bring that positive currents to this side, the sign will change here as minus I3 minus I6 is equal to 0. So the algebraic sum of the currents, at a junction is 0. We are comparing it to the 0 current. 0. So from this what we understand that in a railway station, the number of trains approaching to the railway station has to leave after 1 or 2 minutes. So here has to leave how many trains are approaching, that many trains has to leave. Same number of trains. But here at the junction, towards the junction, the currents coming towards the junction, and we have to see the currents which are going away from the junction. So the algebraic sum of the currents, meeting at the junction is 0. The algebraic sum of the currents at the junction is 0. It is called as junction law. It is Kirchhoff current law. Why we are taking only current? This is according to the law of conservation of charges. This is based on the law of conservation of charges. So here, law of conservation of charge. Why we are taking current? We know that current is equal to charges that are flowing per second. The rate of flow of charges, I is equal to Q by T. The rate of flow of charges, I is equal to Q by T, we are considering. So this is based on the law of conservation of charges. It is called as the conservation of charge. So we are considering as the Kirchhoff first law. Okay? Okay children? Thank you. Thank you children. Make a note of it.